Hello ladies and gentlemen, this is Miss Gokin, and we are still in chapter 3, all about parallel and perpendicular lines, along with the angles that are created when a transversal goes through them. This time we're in section 3-4 or 3.4 about perpendicular lines. Our objectives are prove and apply theorems about perpendicular lines, and our vocabulary, perpendicular bisector, distance from point to a line. We've got 5 different warm-up questions to start with, and I am going to recommend that you turn off the video to work on these questions and then turn the video back on when you're ready to check your answers and move forward. So turn off the video now for the warm-up questions. Anytime you work through problems, it's very important to show your thinking. The way that you show your thinking is by showing step-by-step work. So don't only check your answers, check the work as well. Okay, let's move on. We've got some information given to us here. It says the perpendicular bisector of a segment is a line perpendicular to a segment at the segment's midpoint. Let's draw a diagram of that so we really understand what that's saying. Let's read it again, breaking it down and reflecting on the diagram. The perpendicular bisector of a segment. Okay, so we've got our red segment. The perpendicular bisector means it goes through the midpoint. So it is a line perpendicular to the segment. So we need to show that it's perpendicular. So the perpendicular bisector of a segment is a line perpendicular to a segment at the segment's midpoint. So the diagram reflects what that first sentence says. The next sentence reads, the shortest segment from a point to a line is perpendicular to the line. And if you look over at the new point and line drawn on the right-hand side, you can see that while we can travel many different paths to go from a point to a line, there's actually only one shortest path, and that is the one that is perpendicular to the line. So once again, when we read it, the shortest segment from a point to a line is perpendicular to the line. And the next sentence kind of sums it all up. It says the distance from a point to a line is defined as the length of the perpendicular segment from the point to the line. So what that means is officially the distance between the point and the line is going to be this perpendicular distance that we were just talking about. Okay, let's take a look at example 1. Example 1, distance from a point to a line, and question A says name the shortest segment from point A to line BC. So we just learned that there might be several paths to get between a point and a line. However, the shortest path is going to be the perpendicular path. So that means that the segment that is the shortest getting from point A to point BC is segment AP. And remember the segment symbol that we need to indicate that it's a segment and not the length of the segment. Next, we want to write and solve an inequality for x. Well, this seems a little mysterious at the moment. However, when we think about what we've got here in the diagram, we know that the length of segment AP is the shortest. And we have an expression for the length of segment AC also, but that's going to be longer. So the length of segment AP is less than the length of segment AC. Once we've got that, we can substitute in the distances that are given to us in the diagram. So we're going to say 12 is less than x minus 8. When we solve for x, we move that 8 over. We have 20 is less than x, and remember we can turn that around so that the variable's on the left-hand side. So that is x is greater than 20. That's the inequality for x. To get a little bit of practice with this, you've got to now you try. So I'm going to ask you to turn the video off, work it through, have your work and final answer shown, and then turn the video back on to check your answer. Turn off the video now. The now you try closely followed the example that we just went over together, example number 1. So hopefully you didn't have any trouble with that. Let's take a look at the next 3 theorems in our study. And these 3 all have to do with line positioning. So let's read them together. If 2 intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. And this makes a lot of sense because if we have 2 lines come together, 2 lines intersecting, and we end up with a linear pair, which we will every time we have 2 intersecting lines, we're going to have a linear pair, but these are congruent. So that means it takes 180 degrees and it splits it exactly in half, 90 and 90. Then we know that those lines meet at a 90-degree angle, and we can conclude that the lines are in fact perpendicular to one another. Let's take a look at the next one. The perpendicular transversal theorem. This says, in a plane, if a transversal is perpendicular to one of its 2 parallel lines, then it has to be perpendicular to the other parallel line. And this obviously makes a lot of sense because if 2 lines are parallel, they have the same slope. The line that is perpendicular to one of the parallels must therefore be perpendicular because the slopes will still have the same relationship to the other perpendicular line. Okay, let's take a look at the last one. 3-4-3 kind of turns 3-4-2 around. And so what it says is, if 2 coplanar lines are perpendicular to the same line, so if 2 coplanar lines are perpendicular to the same line, then those 2 lines have to be parallel to each other. And that is the conclusion. So depending on what you're trying to prove, you're going to use different theorems. These 3 theorems, of course, are going to be on the theorem sheet that you get. But we're going to try out now using these new theorems on a proof on the next page. Okay, let's take a look at example number 2, proving properties of lines. We always start by looking at the information that is given to us in the diagram and the information that is given to us in the problem. This says that line R is parallel to line S. So I'm going to go ahead and mark those as parallel. And we are also given the information that angle 1 is congruent to angle 2, and remember the way that we designate that is with arc marks. And using our theorems, postulates, and properties, we want to be able to prove that line R is parallel to line T. Statement number 1 in our proof is the information that was given to us in the problem. So now what else can we say? If we know that lines R and S are parallel to one another, we can also see that angles 2 and 3 are corresponding. And because they are created by a transversal going through 2 parallel lines, we know that those 2 corresponding angles are congruent. So we can write the statement, angle 2 is congruent to angle 3, and the reason is because of the corresponding angles postulate. For the next step, now we know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So we know, because of the transitive property of congruence, that we can also say angle 1 is congruent to angle 3. Now we're at that last step, which, if you remember, we talked about in class, that the last step is always going to be where you prove the final thing that you were trying to prove. And our reason for this is going to be one of the theorems that we just learned, 3-4-1, which says if 2 intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. Unfortunately, we don't have a name for that theorem, so we have to write it out. We successfully used one of our new theorems to prove that 2 lines are perpendicular. And I'm just going to remind you, one of the things that you can do is figure out what you're trying to prove, and that should also point you into the direction of which theorem or postulate you need based on what is the conclusion or the then in the conditional statement. So that can point you in the direction. Now, you've got one to work on. This is a now you try, and you're going to be using one of those 3 theorems that we just learned about. So I'm going to ask you to turn off the video. Remember to mark up your diagram first based on the information that's given. You can see the first line is given to you based on the given right here. So this one is given to you first. Go ahead and mark up the diagram and take a stab at this proof. Turn the video back on when you're ready to check your answers and or get a little bit of explanation about how this worked. Statement number 1 in our proof is about the two angles that are congruent to one another. When we look at that on the diagram, we can see that those are alternate interior angles created by lines EH and FG with that transversal going through them. So once we see that these are alternate interior angles, then we know that line EH has to be parallel to line FG from the converse of the alternate interior angles theorem. Then we can pull in the other given information, that is line FG is perpendicular to line GH. We can see that in the diagram with the little red 90-degree angle symbol. And that allows us then to use theorem 3-4-2, the perpendicular transversal theorem, which says, in a plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. And that allows us to make the statement or make the claim that line EH is in fact perpendicular to line GH. Okay, that does it for the lesson. This brings you to your homework problems. So good luck with all of your practice. And once again, as always, bring in any questions you have into class.